Hello, my name is Dan O'Connell. I'm the Vice President of Sales for North America at FiberStar. In this video, I'll be talking about the benefits of using Citrify in injected marinated meats and poultry products. I'll cover three main topics regarding injected meat and poultry. Phosphates are widely used in injected meat and poultry to increase yields, reduce costs, and improve organoleptic qualities. However, manufacturers also have the option to improve their yield significantly by using Citrify. Another area of interest is phosphate replacement. Some manufacturers are removing phosphates from their brine system due to labeling and health concerns. I will discuss how Citrify can be a phosphate replacement solution in meat and poultry. Lastly, I'll mention a newer use of Citrify within injected products. This involves plating oils onto Citrify to be used in a brine system. Citrify not only delivers the oil, but provides additional benefits within the finished product. There are several advantages to using Citrify in brine systems for injected meat. Citrify is easy to use in the process. There's no specific order of addition. We typically recommend adding the Citrify to the other dry ingredients in the premix. Citrify produces low viscosity, which is important when added to brine systems. If brine systems are too viscous, they tend to create issues during the pumping and injecting stage. Another plus of using Citrify is its small particle size. There are restrictions on how large particle sizes can be before plugging the needles during the pumping process. Due to Citrify's high water holding capacity, it holds water tightly after being injected in the meat tissue. As a result, this improves the yield and eating qualities. It's considered a non-reactive colloid in the brine system. It does not interfere with other ingredients. Brine hold times do not affect Citrify's functionality. Citrify is tolerant to most processing conditions, such as low or high pH environments. There is no thermal step required to activate Citrify's functionalities, unlike some other ingredients in the market. Citrify is heat stable. This natural ingredient binds both water and fat during the cooking process to increase yields. There are several advantages in using Citrify to improve the finished product. Because of the particle size and the fibrous composition, this natural ingredient does not form gel pockets in the meat tissues. Once the Citrify is injected into the meat or poultry, it binds the free water and fat as well as added water to increase yields. This bound water improves the texture, retains the juices and flavor, as well as reduces drip loss. Citrify works synergistically with other hydrocolloids or water-binding ingredients. Citrify can be labeled as citrus flower or dried citrus pulp, which are the preferred labeling options in the meat and poultry industry. These labeling choices provide manufacturers opportunities to clean up their labels for the natural and clean label markets. Citrify is also allergen-free. Lastly, Citrify provides stability. This natural ingredient does not break down over time or in harsh conditions like thermal process or freeze-thaw. Customers ask me about the binding mechanisms that take place when using Citrify. In untreated meats, the muscle fibers tend to shrink and restrict when exposed to increasing temperatures. Here, you can see a muscle fiber fragment at 25 degrees Celsius and 75 degrees Celsius. As the temperature increases, the muscle fiber begins to shrink and purge water. Citrify has both hydrophobic and hydrophilic properties, which gives this natural ingredient its water and oil binding capabilities. Citrify absorbs large amounts of water when it disappears into the muscle tissue due to its particle size and amorphous fiber structure. As mentioned before, the untreated meat fiber is tight and restricted. This is illustrated here as the unswollen lattices. Phosphate and salt brines are typically used in the industry to expand the muscle tissue to hold water, as shown here as the swollen lattice. Additional water holding is achieved when using Citrify in addition to the phosphate and salt. Citrify holds water and fat in place during and after cooking to improve the yields. This is shown here as the pulsating connectors. As mentioned previously, Citrify can be used in addition to phosphate to improve yields and eating quality versus using the phosphates alone. Some manufacturers use this combination to improve the yield significantly, which justifies the incremental cost increase of using Citrify. Here, we have a study done at the University of Wisconsin-Madison showing the advantage of using Citrify plus phosphate. This blend, which is represented as 2 and 3, produced a higher cook yield versus phosphate alone while maintaining the sensory quality. Another study done at Iowa State University validated these findings. When using phosphates in brine systems, there are a few considerations to take note of. Due to the clean label movement, there have been concerns about using phosphates. More so now than ever, consumers are reading labels and avoiding ingredients they negatively perceive. Phosphates have low solubility and dispersion properties. As a result, phosphates are typically used in blends to overcome this challenge. Due to the global sodium reduction initiatives, some manufacturers are looking to reduce sodium content of their products. One way is to use potassium phosphate. Again, low solubility is an issue here with these types of phosphates. If manufacturers have long holding times, they run the risk of the phosphate becoming less functional before the cook cycle. There are approval limitations. Certain phosphates are approved for specific food products. Lastly, there are environmental concerns. Phosphate may cause wastewater contamination issues. There are other phosphate replacement systems on the market. However, each solution has its own limitations. Removing all the phosphates comes with a price. Most phosphate replacement systems available are more expensive than the phosphate alone. Some ingredients, when used alone, like carrageenan, fiber, or starches, have limited functionality. Whey and soy proteins are considered allergens, which is a concern today. And other solutions, such as sodium gluconates, can only partially replace phosphate. There are many advantages when using Citrify to replace phosphates. First, we recommend using Citrify with another water-holding ingredient, such as a carrageenan or rice starch when replacing phosphates. The water holding and yields are comparable or better than using phosphate alone. Citrify, in combination with carrageenan or rice starch, improves texture and eating qualities versus phosphate alone. Also, these blends do not create gel pockets in the final product, which is a plus. Citrify can be labeled as citrus flower or dried citrus pulp, which resonate well with the natural and clean label markets. Lastly, Citrify provides stability when in use. This natural ingredient does not break down over time or in harsh conditions like thermal or freeze-thaw. We ran a study with whole bird chickens at Iowa State University. Here, 0.4% Citrify in combination with 0.4 rice starch increased yields by 4.5% versus phosphate alone. The whole birds had a favorable taste, texture, and other sensory attributes. Another thing to note is the purge loss in addition to the increased yield. Citrify, in conjunction with rice starch, reduces the purge loss. This and the yield-generated cost savings on both raw and cooked chicken. For those looking to eliminate phosphate from their process, there's another Citrify solution available, which is using Citrify in combination with sodium carbonate. Sodium carbonate increases the pH, which opens the meat muscle. As you can see in the illustration, meat fibers at lower pHs like 5.5 are tightly bound. As the pH increases to 7.0, the muscle fibers open so that it can bind more water and increase yields. Citrify holds more water, which improves the yield when used in combination with sodium carbonate. In most cases, to replace phosphate, Citrify needs to be used with another hydrocolloid-like starch or carrageenan. However, if sodium carbonate is used, only the Citrify is needed to replace the phosphate. And if sodium carbonate is considered a processing aid, only Citrify citrus flour is included on the label, which improves the clean label perception. Here, our partners ran a study demonstrating the benefits of using Citrify with sodium carbonate in injected poultry. The Citrify and sodium carbonate combination increased the yield by 4.25% versus using a phosphate-free brine. The pH increased slightly. Here you can see the outcome 1 hour post-injection and after 7 days of storage. The Citrify and sodium carbonate combination had the highest cook yields at both time periods versus a phosphate-free brine or using Citrify alone. The chicken breast was cooked using 2 different methods. One method entailed cooking the chicken in bags, and the other was an open-air cook. The Citrify and sodium carbonate combination produced the least cooking loss versus the other 2 treatments for both cooking methods. This was further proven when our partners tested a Citrify and sodium carbonate combination versus a phosphate control. You can see here that the Citrify and sodium carbonate combination not only outperformed the phosphate control in the cook yield, gross profit per unit, and flavor, but also likely outperformed the phosphate-free brine. This is assumed knowing already that the phosphate-free brines produce low yields and poorer eating qualities. Our partners performed another study using Citrify and sodium carbonate, but this time in injected pork loin. Once again, the pH increased using the sodium carbonate. The Citrify and sodium carbonate combination increased the yield by 3.5% versus the phosphate-free control. Once again, 2 cooking methods were used to evaluate the cooking loss. The Citrify and sodium carbonate combination had the least cooking loss versus the other 2 treatments. The last Citrify use in injected meat and poultry products is plating. Some manufacturers are using specific ingredients with antioxidant effects like rosemary to improve antimicrobial conditions. Because some of these ingredients are in the form of oils, it's difficult to incorporate them into the brine before injection. They typically do not disperse efficiently and tend to float to the top. Some manufacturers are testing Citrify as a plating agent to overcome these challenges. The rosemary or flavored oil is plated onto the Citrify by mixing the oil and Citrify powder together. Citrify can provide between 10 to 25% oil load and at times up to 30%, depending on the type of oils used. The video running is showing how the oil is sprayed onto the Citrify at a pilot plant level. The Citrify's high surface area provides the oil touch points for the oil to bind to. Once plated, the liquid oil is turned into a free-flowing powder. This plated oil is then added to other dry ingredients and added to the brine. The Citrify provides oil stabilization in the brine, but prevents the oil from floating to the top. No additional emulsifiers or carriers are needed. Plating is a more economical option versus spray drying, which can be costly. Once the brine is injected into the meat or poultry, the Citrify continues to hold onto the water and oil, providing increased yields and reduced cook loss in the final product. This concludes the video on Citrify use in injected meat and poultry products. Let's review some of the key points. Citrify can be used with phosphates to increase yield, reduce purge, and improve the sensory attributes. Citrify can also be used to replace phosphates. There are a couple of ways to use Citrify. One is to use Citrify with other hydrocolloids like starches or carrageenans to produce high yields. The other option is to use Citrify in combination with sodium carbonate to target high yields and good sensory results. We recommend using Citrify 100M40 at a level to target 0.3 to 0.5% in the finished product. This usage level delivers an expected yield increase between 4 and 6%. Citrify is typically pre-mixed with other dry ingredients and then added slowly to an agitated brine system. Citrify can also turn liquid oils into flowable powders, which can then be used in marinades to provide oil stabilization. Once the citrify and oil is injected into the meat, the citrify continues to hold onto the water and oil to increase yields and improve juicy texture. I want to thank you for watching the video. We hope you learned a few ways to use citrify in injected meat and poultry products. There are additional videos covering different meat applications on our website. We encourage you to watch them all. If you'd like to schedule a visit or have additional questions, please contact anyone here or visit our website at www.fiberstarringredients.com. Thanks for watching. We look forward to hearing from you.